Hi guys, now we're going to dive into renal clearance. Last week we talked about hepatic clearance. As you know, clearance is probably our most important factor when we're considering dosing regimen changes, so we want to make sure we understand it really well. Total body clearance is going to be equal to all the different organs of clearance. Last week we focused on hepatic clearance, and this week we're going to jump into renal clearance. So how does the kidney actually clear drug, and what determines the clearance of a drug that is cleared by the kidneys? All right, I'm not going to read through all these. You guys can do that on your own. As I said, usually the two organs of clearance that are involved in most drug clearance are the kidneys and the liver. So we have total body clearance being equal to hepatic clearance plus renal clearance. And here's how, if we know the fraction that is excreted unchanged in the urine, which we symbolize as FE, F little e, we can determine renal clearance if we multiply our total body clearance by the fraction that is excreted unchanged in the urine, because drug that is unchanged is parent drug. Therefore, it has not been metabolized by the liver. So whatever is not being metabolized is going to have to be excreted in the urine. So whatever is excreted unchanged in the urine as the parent drug, not metabolized, that's going to be renal clearance. I mean, most of the drugs go out in the urine, but they might go out as a metabolite. If they go out as a metabolite, they've already been cleared by the liver by being changed into something new, being metabolized. I hope that's clear. So if we know that, so the FE, the fraction that is excreted unchanged in the urine, if it is 0, that means we're going to assume that it's totally cleared by the liver, because none of the drug is coming into the urine as parent drug. It's all being metabolized, therefore it's all cleared by the liver. If FE is 1, that means 100% of the drug is being found in the urine unchanged, which means 100% of it is cleared by the kidney. Now, I don't want you to worry about this too much, but I want you to realize that there's renal blood flow that's coming in to the nephron. Here's our glomerulus, and then here's our nephron, right? So we have drug coming into the kidney. So renal plasma flow is about 20 to 25% of our cardiac output. Our cardiac output is 1.2 to 1.5 liters per minute. So remember, with any clearance, it's going to be Q times E, so we need to understand the blood flows here, right? The renal blood flow is 20 to 25% of this, and then our renal plasma, so if we did the math, I'm not going to just because it's not that important, but you can do it. The renal plasma flow, remember plasma is blood minus the red blood cells, so you have to consider the hematocrit there. So your renal plasma flow is going to be between 0.66 and 0.83 liters per minute. And our glomerular filtration rate, so our glomerular filtration rate is the blood coming into the glomerulus, is 125 to 150. So we consider it to be 125 mils per minute is our normal average GFR, which is filtration through the blood flow that filters into the glomerulus. And then this is into our tubule. I'm sure you've already had your I hope you've already had your renal physiology. So we've got the glomerulus that's really just a filter as a drug comes into the nephron. So when the drug does come into the nephron, basically what we've got going on is the drug comes in through the the glomerulus, which is a filter here. So we've got filtration happening here. This is to keep the big stuff here in the blood, and then we don't want to be letting any proteins or any things that are hard to make. Now this is in the tubule, right? So we've got the blood being filtered into the tubule, and as you move down through the tubule, eventually you're going to make it to the bladder and then out of the body. Obviously this is not really physically how it looks, but we've got, here is the, we're going to call this the proximal tubule, which means closer, right? So this is the proximal tubule, and then this will be the distal tubule. We have three things happening here. The first thing is drug will come in through the blood. It's going to be delivered to the glomerulus, and it either will, the blood will either go through here or it won't. The drug will either go through here or it won't. Basically, if a drug is bound to a big honking protein, here's our drug and here's our protein, it's not going to fit through this glomerulus. So only unbound drug will make it through this filter. Well, why would that be? Well, because we don't want proteins to, we don't want to be peeing proteins out. Protein is really hard to make. It takes a lot of resources, so it would be silly to be peeing that out. We want to, and it's not hurting us. We need protein. So if you have protein going through here, you have something wrong with your glomerulus, don't you? So we want to make sure that we know that if our drug is bound to protein, it's not going to be filtered into the nephron. It's going to stay in the blood. Okay, so that's your first thing, is we've got our filtration. Then the next thing that happens in the proximal tubule is we have drug. We can have drug added from the blood to the nephron. We can have drug. So if we think of this as the bloodstream, we can have drug move from the blood into the nephron. This is called secretion. And it is an active process. What does an active process mean? It means that it takes energy, and we're going to talk more about that. But drug can be moving from the blood into the urine. So drug is being moved from the blood into the urine in the proximal tubule by tubular secretion. And then as we move through here, what's happening as we move through the nephron? Well, one of the big things that's happening is we are reabsorbing water. Because we don't want to have all of this water go out in the urine. Because again, we need water. Water is important to our bodies. We're, 3/4 water. So we don't want to just be peeing water out all the time. One of the things that I can tell you is, remember filtration clearance. Remember what the GFR is about 125 mils per minute. So about 125 mils per minute of blood is being filtered through that nephron. How much do you think our urine output is? It's about 1 mil per minute. So what's happening big time is water reabsorption. So this is all being concentrated as it moves down the nephron to the bladder. Big time concentration, because we're taking water back into our bodies because we need that water. So what's happening to our drug concentration? If there's drug in here, it's becoming more and more concentrated as it moves through here. So the other thing that happens is we have reabsorption. So drug can be reabsorbed from the nephron, taken out of the nephron, and go back into the blood here in the distal tubule. So we have three processes. Filtration, first the drug has to be filtered. Only free drug can be filtered. Then we can have secretion. This is an active process where drug is being moved from the blood into the urine. And then last but not least, in the distal part of the tubule, we can have reabsorption. So drug will be moving from the urine back into the blood before it goes out in the urine. Okay, so as I just described, we have two processes that I never can remember how to do this now. Okay, hit that twice. Remember that, Sandy. There's three processes altogether. There's two that remove drug. So there's two that take drug from the body, so it's going out in the urine. Filtration will add drug to the tubule, and active secretion adds drug to the tubule, plus to go out in the urine. And then one that returns drug to the body, which is reabsorption. Reabsorption is coming from the urine back into the blood, isn't it? So we have three processes, two that are adding and one that is subtracting from the urine. So here's what describes our renal clearance with all of the processes. So here's our total renal clearance. We have the clearance of filtration plus the clearance of secretion. These two are adding drug to the tubule to go out in the urine, right? And then a fraction of that will be reabsorbed. So whatever's left from that's being reabsorbed, well, 1 minus the fraction reabsorbed will be the fraction remaining in the tubule. So this will give you our total body clearance. So you'd have to add these two together and then multiply times the fraction remaining, because these happen in series, adding together, and then this will happen after you've got the sum of those two clearances. So here's another picture that shows all this. So we have our renal plasma flow and our GFR that goes through the glomerulus. Only free drug will be filtered. Then we'll go into the proximal tubule, and now we have blood flow around the tubule. This is all the blood that's kind of surrounding it. And then the drug will go into this is the proximal tubule where the urine is being made. And then we can have active secretion, can't we, from the blood? We can have active secretion into the tubule, which will add more drug to the tubule. Now this is all water reabsorption as we move down through the tubule. And then we also have reabsorption of drug. So we can have drug secreted in, and then we have drug that comes back out, reabsorption before going to the bladder. And out of the body. So in summary, well, we'll learn about this more, but all drugs are filtered. Drugs don't get a choice when they're coming in through the blood. They don't get a choice whether they go through that filter or not. All drugs will go through that filter. So all drugs will be filtered. Now, only some drugs will be secreted and some drugs will be reabsorbed. Not all drugs will be secreted and not all drugs will be reabsorbed. Each drug will be either predominantly secreted, in other words, they could be both secreted and reabsorbed. So here's our tubule. So we have secretion and reabsorption. We can have drugs that are both secreted and reabsorbed, or just secreted or just reabsorbed, but in the end they'll either be predominantly secreted or predominantly reabsorbed. So one or the other will take precedence. The way that you can figure that out is by comparing your renal clearance to your filtration clearance. So let's think about that for a minute. So we've got drug that is being filtered. Okay, so that's how it enters into the nephron. So here's our tubule. And then we're going to have secretion, and we're going to have reabsorption. So this is reabsorption, this is secretion. And then we're going to have the drug go into the bladder and out of the body. So drug is filtered here, comes through the tubule. Maybe there's secretion happening, then maybe there's reabsorption happening, and then eventually it goes out. If we compare our filtration clearance, so how much drug is actually filtered into the body or into the nephron, if we compare that to our actual renal clearance, which tells us the actual renal clearance, what is actually renally cleared, if we compare those two, we should be able to tell which is the predominant process. Okay, so if let's say the filtration clearance is 100 milliliters per minute, and let's say only 50 milliliters per minute is our actual renal clearance. So if 100 mils per minute comes in and only 50 mils per minute comes out in the urine, what does that tell you must have been happening predominantly? Well, it must be being predominantly reabsorbed, right? Because there's less going out, so it must be going back into the blood. Okay, let's do the opposite now. What if let's say 90 mils, no, sorry, not that. Let's say 45 mils per minute is being filtered. So 45 mils per minute is coming through this filtration, this glomerulus into the nephron. And let's say 75 mils per minute is coming out in the urine. What does that tell you must be happening? Well, there the predominant process must be secretion. Drug is being added to the urine from the blood. That's why this number is bigger than this number. So in order to determine what the predominant process is, you need to compare renal clearance, which is what's going out here, to our filtration clearance, which is what's being introduced to our nephron. So let's think about that for a minute. So if our renal clearance is greater than our filtration clearance, so again, here's our filtration, comes in, here's our bladder going out. So what's happened? Our renal clearance, this is larger than our filtration clearance. So there's more going out than was introduced by filtration. So that must mean that it's predominantly secreted. More drug is being added to the nephron, isn't it? Okay, good. Hopefully you see that. What if our renal clearance is less than our filtration clearance? So our renal clearance is less than what was filtered. So we have an amount of drug that's filtered in here, right? But what goes out is less, then it must be being reabsorbed, right? So here we're predominantly reabsorbed. You can measure this by the excretion ratio, but we're really not going to use that. I'm going to just give you these two numbers, and you're going to have to figure out, was it predominantly secreted or predominantly reabsorbed? All right, that's it for this one. We'll see you and talk about filtration clearance next.